In this section, we'll be talking about reflection, a wave property. Reflection, in a very simplistic manner, is the bouncing of a wave off a surface. So examples of reflection in everyday life would be the reflection of a light wave, such as looking at your image in a mirror. If I'm standing here, I see my reflection in the mirror. The light waves that are coming off of me, in other words, reflecting off of me from the sun, then reflect off the mirror and come back to my eyes, and I see the reflection. That's the reflection of a light wave. What about a sound wave? Can sound waves reflect? Of course they can. An echo is an example of a reflection of a sound wave. If I make a sound and it reflects off the wall and I hear it a second time, then I've just had a sound wave reflect and it created an echo. Now let's look at two examples of light waves reflecting and the two different kinds of reflection that can occur. One type of reflection is called regular reflection. The other type is called diffuse reflection. We'll talk about regular reflection first. Regular reflection occurs when a wave reflects off of a smooth surface, like a mirror. A mirror is a good example. A mirror is a good example of a smooth surface that will cause regular reflection. So here's the mirror. I'm putting it down flat. We have light rays coming from, for example, from the sun. And we like to think of those waves as being parallel to each other. So here they come, parallel to each other. I'm trying to very carefully draw them parallel to each other. And so when they reflect off this very smooth surface, they also reflect parallel to each other. That means that the image will not be distorted. If we put a little eye over here, in other words, that somebody is looking at the image, they will see a clear image, right? Regular reflection produces a clear image. Regular reflection produces a clear image. In other words, this person will see an image that is not fuzzy. They will clearly see the image. Right, now another example of reflection is diffuse reflection. And I'm going to erase this because I'm going to need a little bit of space to do diffuse reflection properly. So if you want to copy that, take just a minute to get that copy. All right, so the next kind of reflection is going to be diffuse reflection. Diffuse reflection. Diffuse reflection occurs when a wave bounces off a rough surface, a surface that is not so smooth. So let's draw an exaggerated rough surface. I'm really going to exaggerate this to make the point here. All right, that's a very rough surface. And we can have the same light coming down from the sun. Right, here's the sun. And the light coming down from the sun comes in parallel rays. Now, here's one. Here's another. And again, we'll try to do this parallel. Here's another parallel. All right, and here's one more parallel. We'll put it over here. All right, so all these rays are meant to be parallel. I hope my drawing is pretty good. Now we're going to reflect those rays off of this rough surface. And you'll see when this one hits, it reflects off this way. When this one hits, it reflects off that way. When this one hits, it reflects here. And when this one hits, it reflects kind of backwards a little bit. As you can see, although the rays came down parallel, they were not parallel after they reflected. So this kind of reflection will not produce a clear image. Diffuse reflection does not produce a clear image. The image will be fuzzy. Okay? So we've looked at these two basic types of reflection. Now let's look at reflection in more detail and look at some of the quantitative aspects of reflection. The law of reflection states that the incident angle is equal to the angle of reflection. Let's see how that works out. Here we have a surface, and here we have an incident angle. The incident just means the first, or the beginning. So this is an incident ray of light. This is the incident ray. I'll show you the incident angle in just a minute. So the incident ray comes down, and we also need to draw something called the normal. The normal is an imaginary line perpendicular to the interface between two surfaces. The normal is an imaginary line that has to be drawn perpendicular to the interface between two surfaces. The normal is also at the point where the incident ray hits. It has to be perpendicular, and it has to be at the point where the incident ray hits. All right, take a moment to copy that, and then I think we're going to erase it so we have more space on the board. And we'll talk about the law of reflection. Now I'm going to show you the normal right now. It has to be perpendicular to the surfaces, and it has to be at the point where the incident ray hits. So let's do that now. And remember, the normal is an imaginary line. So I'm going to draw the normal as a dotted line. So you remember that it's an imaginary line. Now, here's the interface between the two surfaces. All right, here's my, we'll call this again a mirror or a piece of glass. Mirror or glass. In any case, the light is going to reflect off of that surface. So here's the interface, the place where the air, let's label that, the place where the air meets the mirror or the glass. So imagine a piece of glass on the ground or a mirror on the ground, and we're going to draw the normal perpendicular to that. So you can see that these two lines, this line and this line, are perpendicular to each other. All right, I could draw a right angle there for emphasis. All right, there's your right angle. That's a 90-degree angle. So these two are perpendicular to each other. So let's draw the normal. All right, perpendicular. All right, so here we go. There's the normal at the point where the incident ray touches the surface or hits the surface. Right there. There's my normal. And I'm going to label that normal. Right, it's an imaginary line. Now, the incident ray comes down, the reflected ray reflects back up. But let's take a look at the law of reflection. The incident angle. Where is the incident angle? The incident angle is right here. I'm going to label it theta I for incident angle. And I'm going to define the incident angle. The incident angle is the angle between the incident ray and the normal. So the incident angle is the angle between the incident ray and the normal. We could measure that angle with a protractor. Here's my protractor. And right about now, that is starting up at 90, 10, 20, 30, 40. That's about a 40-degree angle in here. My incident angle here is about 40 degrees. Now, the law of reflection says that the incident angle is equal to the angle of reflection. So that means when this light ray is reflected, the angle of reflection, which is going to be in here, has to also be 40. Exactly. So from 90, we've got 10, 20, 30, 40. Right there is where I want my reflected angle to be. All right. So that's my angle of reflection. You can put theta r. I like to put theta REFL because that will distinguish it from angle of refraction, which would be REFR. Or you can put just R. All right, theta R. So, this is the incident ray. This is the reflected ray. This is the incident angle. This is the angle of reflection. Let's define angle of reflection. Right here. The angle of reflection is the angle between the reflected ray and the normal. The angle between the reflected ray and the normal. All right, so what the law of reflection is saying is that these two angles must be equal. The incident angle must be equal to the angle of reflection. Now, I'd just like to show you a slightly more complicated series of reflections just to show you how a more sophisticated problem would progress. So let's draw a series of mirrors we'll draw a mirror here, and then a mirror here, and then another mirror here. Now this is just a sketch. We're not actually measuring any of this, it's just a sketch. All right? So in this case, what would happen if this were the incident, ray? Incident ray. Well, this would be the normal. Right? Now that's perpendicular to this surface. All right? Remember, this is a mirror, this is a mirror, and this is another mirror. We've set them up in a sort of a half hexagon shape here. Now, since this is the surface, there's the normal, perpendicular to the surface. And this is your incident angle here, theta I. So what would happen is that this would be reflected right about there. And the incident angle and the angle of reflection would be equal. Now this ray will hit this part of the mirror. And here's another normal. All right, this is going to hit right down here. All right, here's my new normal down here. Another normal. And this angle, another theta incident. And this angle, another angle of reflection, will have to be equal. So I'm going to try to draw those basically equal. All right? And he's going to, not a good drawing. Well, in any case, you get the general idea. It's not a perfect drawing. It's off a little bit. All right? So he's going to come out like that. So you have an incident ray and a reflected ray. Then this reflected ray becomes the next incident ray, and it reflects again. But this angle and this angle should be the same, must be the same, and this angle and this angle must be the same. I think we should measure those angles, because I think they're off a little bit. This angle is 10, 20, 30, 45 degrees. This angle is 10, 20, 30, okay, right about there is where it should be. All right, let's fix that angle so that it's accurate. I should have used the protractor the first time. All right, so that would be more like here. Okay? Yeah, that's more like it. In a case if this was a real hexagon, this would come in straight, bounce off of there, and come out straight. Now, of course, it all depends on exactly how you have all these mirrors oriented, but you get the general idea. Let me show you very quickly also how light would reflect off a spherical surface. And again, the tricky part is drawing the normal. Let's do this one on this side. All right, so here we have a spherical surface, and we can have light coming in straight again and hitting here. Now, here's your normal, all right, because you've got, it's hitting this part, all right, so there's your tangent to that circle, all right, that's the surface. There's your perpendicular normal. So that's why the normal, I drew the normal where I did. When this comes in, it's going to reflect that way. So there's your incident angle and your angle of reflection. What happens if the light hits here in the center? Get a little more centrally located. Right here in the center. If it hits here, all right, it's going to bounce straight backwards. because your normal would be right about here. Okay? Here's your tangent to the circle. There's your normal. All right, take a look at that. Here's your tangent line to the circle. That's the surface. Here's your normal. All right? So the angle coming in is 0 degrees. The angle going back out again has to be 0 degrees. We'll try one more. What if we bring it in at an angle? Instead of having it come straight in, let's bring it in at an angle. Erase that. And see how it reflects off. All right, there's my spherical surface. Well, what if I bring this in at an angle and it hits there? All right, here's my normal. All right, and it's going to bounce off something about like that. So here's my angle, my incident angle, my angle of reflection. Okay, just to review, this is the incident ray, the incident angle, the normal, the reflected ray, and the angle of reflection. And remember that the angle of incidence must be equal to the angle of reflection. You can write that symbolically. Theta incident equals theta reflected. And again, if you like, you can put REFL for reflected. Or you can just put R. Okay? So that is a symbolic version of the law of reflection. The angle of incidence is equal to the angle of reflection. I hope that you've enjoyed this little summary of reflection. In the next section, we talk about refraction, and I really want you to see how reflection and refraction are not the same thing.